This is a total production. Hello, Chem Minions. Total coming at you from my laundry cave yet again. So this is going to act as our Chapter 5 practice. So for this set of practice, we're really going to be just looking only at alkenes, whether they are easy. I'm also going to throw in the cis-trans to kind of make sense of those, and then also looking at some stability of alkenes. All right, so as we look at these two sets right here, it wants us to identify the E alkenes. All right, so what does it mean to be E? Sometimes there are certain situations where alkenes, right, can be either what we call, so something like this guy right here, right? You've got these two alkene carbons. All right, and if you notice, like if I kind of turn this page this way, you can kind of see how you've got a CH3 group on this carbon and a hydrogen there. So when we talk about priority, like even going back to the same rules we used for chirality, here you have your higher priority group on the top of this double bond. And then you go to this other alkene carbon and you've got a CH3 here, and it's understood to be a H there. So then you've got the higher priority group for this carbon on the bottom. So these two higher priority groups per carbon, right, are on opposite sides of the double bond, right? And so this can be called either trans or E, okay? Now, once you start getting into more than two groups, so here you have two groups. Hydrogens don't really count. So once you start talking about having, say, a methyl and an ethyl here, we can no longer use terms like cis and trans. We have to solely rely on using terms of E and Z. All right, so when there are three groups other than hydrogen or four groups other than hydrogen, you have to use only E or Z when we talk about naming them. Okay, so let's look at what we got here. Hopefully what you can kind of tell here for this guy, right, the two, with respect to the double bond, we have a higher priority group here, and then the higher priority group there, per carbon, right? And so hopefully you can kind of tell this is trans, but also that's the same thing as E for this, because this is di-substituted, okay? So I'd circle this one as being understood as an E. Now in this one, we can't actually use cis-trans or EZ, either one, because on this carbon in particular, you have two methyl groups. So because both of these groups are the same, we can't think of, because it's the relationship per carbon. So when you look at these two carbons, here you have a methyl and a hydrogen. And you would say, okay, well that's the higher priority group. But then over here, I can't pick a higher priority group on this carbon, so I can't talk about the relationship of EZ or cis-trans, right? So I can't, this is actually not, there's no E, no Z, no cis, no trans for any of it, because these two are the same groups. All right, now we look at this guy right here, and we've got the methyl group on this carbon, so that's the higher priority group. And then over here on this carbon, we're comparing a methyl and an ethyl. So if you recall, right, the ethyl is a higher priority group. And so what you can kind of see is both of these groups are on the same side. So that's not an E. This is a tri-substituted, but the two higher priority groups are on the same side of the double bond. So this is actually a Z, not an E. We can't use that. All right, so let's look here at that double bond. All right, so when we look, you've got an understood hydrogen up there. So the higher priority group is the methyl on this side. And then when you compare these two groups, methyl versus propyl, that's the higher priority group. So if you notice yet again, right, they're on the same side of the double bond. So this is another Z, not an E. All right, if we look at these two carbons, because we have a methyl and a methyl here, right, this one carbon that has the double bond, right, it has two of the same groups. I can't label this as E, I can't label it as Z, I can't label it as cis, I can't label it as trans. So because of that, there's really no naming I can use for this one. And the same goes for this one, because on this carbon right here that has a double bond, it has two hydrogens. So because it has two of the same, even though we don't tend to consider that like the grouping part, it's got two of the same things on the carbon that has the double bond, so I can't use it. Now if we look here, at this double bond, right, this carbon has a methyl and an understood hydrogen, so that's automatically the higher priority group. This carbon has that whole ring and an understood hydrogen, so that's the higher priority group. And so if you notice, if I turn it this way, right, you've got a methyl on the top, and then you got this big old ring on the bottom. They're on opposite sides of the double bond. So this one we could call either E or trans, and so I'm going to circle it because I have to circle the E ones. And then let's look, what do we got here? We've got the two carbons with the double bond, and so on this carbon it's easy because there's a methyl and an understood hydrogen. So here you got the higher priority group. Then you look at this carbon, and it's got a methyl and it's got that big old ring. This big old ring, right, that guy's definitely the higher priority group. And you notice, right, if I turn it this way, you can see they're on the same side of the double bond, right, the methyl and the ring. So this is not an E or trans, right? This is, that would be a Z, okay? I wouldn't name it cis, okay? But because this E and this E, they only had two groups across the double bond, that's why I labeled these as E or trans, okay? Now, if you, hopefully what you might notice is that these are the same 4, right? And then these down here are the same 4. So what you can see is I can go ahead and just cross out these two because we've already identified those as E from the previous question. Now when we go back, right, remember I said because this carbon right here has 2 methyls, right, I can't label this as E or Z because it has 2 of the same groups on that double bonded carbon. So I have to exclude that one, so I'm going to put an X through it. Here, on that carbon, the higher priority group's the methyl. Here on this carbon, it's a ethyl versus a methyl, so it's an ethyl. And so if you notice here, right, if I turn it that way just a little bit, right, they're both on the bottom of the double bond. So because of that, they are on the same side. So this would be a Z, right? I wouldn't label this one as cis because it's tri-substituted. I can only use cis when it's di-substituted. So this is a Z, so I can circle it. And then we look here. So there's the double bond. So first looking at that top carbon, it's got a methyl and an understood hydrogen. Methyl's the higher priority group. And then on this bottom carbon, you have a methyl and a propyl. That's the higher priority group. And so yet again, you see higher priority group and higher priority group are on the same side of the double bond, right, on the left. And so because of that, I know this is also a Z, and I can circle it. I cannot use cis for this one because it is tri-substituted. Cis and trans, I can only use with di-substituted. All right, here we go. So the problem with this one, you have a methyl and a methyl. So I can't use E or Z. I can't use cis or trans for this one. So that's the same problem we have for that one, right? So I'm going to just cut through it and say, nah, ignore. This one right here, we've got 2 hydrogens on it. So this one has the same problem as this one and this one. So we can't use cis or trans. We can't use E or Z. And then our last one, we've got on this double bonded carbon, we have a methyl and a hydrogen. So we have higher priority group there as the methyl. And then on this carbon here, we've got a methyl and the ring, and we already said before in the previous question, the ring's the higher priority group. And you notice they're both on the bottom side of this double bond, so they're on the same side. So this is yet again another Z, but I can't use cis for this because it's tri-substituted. It's got a methyl, a ring, and a methyl, so it's got 3 substituent groups on it. I can't use cis, so I'll circle that one as well. Okay, so hopefully this kind of helps you in looking at your EZ or cis-trans naming. All right, next up, it says for each set, so I'm just going to compare all of these, and then separately I'm going to compare all these. So it says for all of these chain ones, it says for each of the alkenes, circle the most stable. All right, so what does it mean to be most stable? We're going to follow a guy named Zaitsev, his rule, Zaitsev's rule, right? The most stable alkene, so most stable equals highest substituent count. All right, so the more substituents around that double bond, the more stable it is. So really what we're going to do is we're just going to count how many substituent groups each double bond has. So for this one, you don't count hydrogens. Okay, so for this one, we only count this and this, right, all of that. So this has a count of 2. All right, this one right here, right? You've got one on this side, right? All of that stuff. And then you got one on this side, all of that stuff. So that has a count of 2. Now technically, this one's trans, and then this one's disubstituted. So there is a difference in that stability. Trans is actually going to be the most stable. For disubstituted, cis is going to be the least stable. Okay, let's look at this one. So this guy has 1, 2, 3, 4. So that has a total of 4, right? Okay. Let's see, what's this one got? And that is the most substituents we can get for a double bond, so I'm banking on that's going to be the most stable. But let's go ahead and count the rest of them. So this carbon has 1, 2, so we got 2 on that side, and then this carbon has just 1. So it would be 2 plus 1, or 3. Okay, and then let's look at this one. It has 0 on that side, and then on this carbon it's got 1. So it has a total substituent count of 1. So our least stable is this guy right here. And our most stable would be this one. Alright, so I'm going to circle that guy right there. I'm going to box it in. So, because it has a total substituent count of 4 around it. This one's the least stable because it has a total substituent count of 1. Okay. But it didn't care about the least. I just went ahead and told you which one was least. Alright, and lastly, doing the same thing again, let's look at each set. So we have... So on this one, we've got 1, and then on this carbon, we've got 1. So it has a total substituent count of 2 across the double bond. See, this one has 0, and then this one has 1, 2, so it has a 2. So it has a total count of 2. All right. Let's see, what does this guy got? It's got 1, 2, so 2 on that carbon, and then on this other double bonded carbon, it's only got 1. So 2 plus 1 would be 3. Alright, so this is the highest and the most stable so far. What's this one got? It's got 1 here, and then on this one it's got 1, 2. So 2 and 1. So that would be a total of 3. Oh, so those two are equaling out here. Alright, let's see what else we got. Alright, we've got on this carbon, it's got 1, 2. Alright, so it would be 2 for that carbon, and then on this double bonded carbon it's got 1 and 2. So it is going to be this guy, a total count of 4. So that's going to be our most stable. Alright, went ahead and wrote most stable there. And then we have 2 that are disubstituted. And so when we look at the stability for those, technically the way it works for disubstituted, it's cis is less stable, trans is most stable, and then in the middle is when you have 2 groups. So it's di on 1 carbon. So technically this is the least stable. Okay. All right. So hopefully this helps for you with some practice. All right, well, until next time, stay weird.